Assalamualaikum. Today I am going to discuss with you some problems from mechanics. I select these problems from the HSC, that means higher secondary books of higher secondary books of Bangladesh. Bangladesh student who follow the books, who study in the Bangla medium or English version under national curriculum, they will be benefited, I hope. Okay. Here I choose some problems. In previous lecture I discussed with you about some theorems, but today I have brought some problems for you. First problem is two forces here, 2p and q are acting at a point. If q is equal to 3p and the first be doubled and the second is increased by 6 units, then the resultant is unchanged in direction. We have to find the value of q. Here two forces 2p and 3q acting at the point here, and the angle between them is alpha, where q is equal to 3p. If the first force is doubled, that means first 2p becomes 4p and the second is increased by 6 units, then the resultant is unchanged in direction. We have to find the value of q. So angle between the resultant and the first force is theta here, so tan theta is equal to the q sin alpha. Here q is 3p sin alpha, p plus q cos alpha. Here q is 3p cos alpha. We know this is the formula of the direction of resultant. And again, when the forces are 4p and 3p plus 6, then tan theta is equal to 3p plus 6 sin alpha and divided by 4p plus 3p plus 6 cos alpha. So both we get from the direction formula of resultant. Then we can say that these are equal. Okay, this one and this one both are equal. From 1 and 2 we get this. Okay, and from this line, after by doing algebraic calculation, we have to find the value of q. Okay, so first we take the cos term in the same sides. By interchanging, we can bring this term into we can bring this sine term into denominator. Here you can bring this into here, and similarly we can bring this term into here. Okay, so now now we get this here. If we subtract minus 1 from both sides, then we get 2p plus 6 cos alpha, 2p plus 3p cos alpha, and in the right hand side we get 6 sin alpha divided by 3p sin alpha. Here 2p plus 6 cos alpha divided by 2 plus 3 cos alpha. Here 2 by 1, so we get p plus 3 cos alpha is equal to 2 plus 3 cos alpha. So we get p is equal to 2 Newton and q is equal to 3 times 2, 6 units. Okay, now two forces of magnitudes, another problem here, where two forces of magnitudes p and q act at a point, and the magnitude of their greatest and smallest resultant are f and g respectively. If the angle between the line of action of the forces be alpha, then we have to prove that the value of the resultant is root over f square cos square alpha by 2 plus g square sin square alpha by 2. Okay, let the two forces be p and q, where p greater than q. According to the question, p plus q is equal to f, p minus q is equal to z. By adding these two equations, we get p is equal to half f plus z. By subtracting, we get q is equal to half f minus z. So if r be the resultant of the two forces, then r square equal to p square plus q square plus 2pq cos alpha. We substitute the value of pq, then we get r square equal to f by 2 plus z by 2 whole square plus f by 2 minus z by 2 whole square plus 2 times f square minus g square by 4 cos alpha. So here we get a plus b whole square plus a minus b whole square. So we get 2a square, 2 half times a square plus b square. Okay. And here 2 times f square minus g square by 4 cos alpha. So we get here if we take common half f square, we get 1 plus cos alpha, and half g square we get taking common we get 1 minus cos alpha. So it becomes f square cos square alpha by 2, and it becomes f square sin square alpha by 2. So this is the required this is the resultant we get after calculation. Now next, another problem here where two forces P and Q acting simultaneously on a particle, and their resultant makes an angle 60 degree with the force P. If the force P is doubled, then this angle be the half of the previous. We have to determine the angle between the forces P and Q. Okay, now this is the formula P and Q here, and the angle between them is alpha. This is theta. Theta is equal to 60 degree. And if the force P is doubled, then the alpha is same here, and theta by 2 is 30 degree. Let the forces P and Q acts at an angle alpha, and the resultant makes 60 degree. Theta is equal to 60 degree with the force P. So tan 60 degree is equal to q sin alpha divided by p plus q cos alpha. So root 3 is equal to q sin alpha divided by p plus q cos alpha. So we get q sin alpha is equal to root 3 times p plus q cos alpha. If the force P is double, then the resultant makes angle with the force 2p. So tan 30 we have used here, we have used direction formula of the resultant, which is tan theta is equal to q sin alpha divided by p plus q cos alpha. So tan theta is equal to q sin alpha divided by p plus q cos alpha. So we put the value of tan 30 here. By using this formula, we get 1 by root 3 is equal to root 3 times p plus q cos alpha and 2p plus q cos alpha. Please notice here, after this line we substitute this q sin alpha by this, okay, by equation 2. Okay, so that's why we get root 3 times p plus q cos alpha here, and by cross multiplication we get the value of, finally we get the value of p is equal to minus 2q cos alpha. And we apply this, if we apply this p is equal to minus 2 cos alpha in equation 2, we get q sin alpha is equal to root 3 bracket minus 2q cos alpha plus q cos alpha. So that means tan alpha is equal to minus 3, tan alpha equal to minus 10 root pi by 3, tan pi minus pi by 3. So alpha is equal to 120 degree. Okay, now another problem. Here in this problem, the problem is two forces act along the sides CA and CB of the triangle ABC, and their magnitudes are proportional to CA, cos A and cos B respectively. We have to prove that their resultant is proportional to sin C, and its direction divides the angle C into two portions, half C plus A minus B and half times C plus B minus A. Two forces P and Q act along C and CB. The resultant R is equal to root over P square plus Q square plus 2PQ cos alpha. Here P is equal to K cos A, because cos A act along C A. So if we can take P equal to Q K cos A, and CB is equal to K cos B, and 2 K cos A times K cos B K cos C. Taking common k square, we get cos square a plus cos square b plus 2 cos a cos b cos c here. By using this formula, we can write cos square a plus cos square beta plus 2 cos a cos b cos c is equal to 1 minus cos square c. So we get r equal to k sin c. That means r is proportional to sin c. Now next, we also have to find the first we have to show the r is proportional to sin c. Then we also have to show the direction divides the angle. That means we have to use the direction formula of the resultant. Now we know the direction formula of the resultant is tan theta is equal to q sin alpha divided by p plus q cos alpha. By applying this formula, we know q is equal to k cos b here and p is equal to k cos a here. By substituting the value, we get cos b sin c. We can cancel k from numerator and denominator, and we can substitute a by 180 degree minus b plus c. So cos b sin c divided by minus cos b plus c plus cos b cos c. Cos b sin c divided by k minus cos b cos c plus sin b sin c plus cos b cos c. These two terms will cancel each other. So cos b sin c divided by sin b sin c. Here we get cot b. We can substitute b by 10. We can write it 10 90 degree minus b, and also we can write 90 degree by a plus b plus c by 2. So we get 10 c plus a minus b by 2. That's why we get theta is equal to c plus a minus b by 2 and c plus b minus a by 2. Next, here another problem. Three concurrent forces 2, 4 and 6 newtons units are acting respectively along the lines parallel to the sides AB, BC and C of an equilateral triangle ABC. We have to find the resultant. We know the angle of every angle of the equilateral triangle is 60 degree. So here this each angle will be 60 degree, but this angle must be what 120 degree, because the total angle is 180 degree. So if we subtract this, we get this portion must be 120 degree. See, if we this is a equilateral triangle and three forces acting along BC, CA and AB. We can write this the direction like this. Three forces 2 Newton, 4 Newton and 6 Newton the angles between them 120 degree. Now if we take the resultant of these forces along this line, which are in theta degree with these forces, this line, that means their resultant makes angle with BC theta. We assume this. So r cos theta must be 2 cos 0 degree plus 4 cos 120 degree, since the angle between 4 and 2 Newton, this two line is 120 degree, this two line is 120 degree. Okay, so that's why here 120 degree we used here. But for 6 Newton, the angle between, if we take this direction, this becomes clockwise, so this must be, that's why we have to bring minus sign here. Okay, so this is, if we use this direction, here we use this direction, so that's why this is minus 120. So now 2 minus 4 times half plus 6 times minus 1 by 2, that's why r cos theta is minus 3. Similarly, if we take r sin theta, 2 sin 0 plus 4 sin 120 and 6 sin minus 120, so r sin theta is minus root 3. So r square is equal to 9 plus 3 12, which is r is equal to 2 root 3 Newton. And if we take tan theta, which is r sin theta divided by r cos theta, we get 1 by root 3. We can convert this into theta is equal to 210 degree. That's the problems I supposed to bring you for today, for you, all of you. I hope these problems will help you to understand the topics statics more comfortably for you. And please suggest me if you have any problems. I can bring in that problems for you in my next videos. And please support my channel. Your support will inspire me to work for you. Thank you everyone. Assalamu alaikum.